When you do electrical circuits in physical science, you'll come across something called the series connection and a parallel connection. Now, with a parallel connection, it's very interesting because when you work out the total resistance of that parallel circuit, so say for instance, you've got a circuit going this way and you've got a 1 ohm resistor, and you go this way and you've got a 3 ohm resistor. Together, they need to give you a resistance that you can actually replace with one resistor in line. Those two can be calculated to be replaced with one. Now that calculation of parallel resistors is what you can use when you are faced with a question in mathematics about two machines, or three or four, doesn't matter. When you are faced with a scenario where one machine or one man or something can do a certain amount of work in a set time, another machine or another man can do the same amount of work in a different time. If they work together, how long will it take them? And you use that same logic that you use in electrical circuits, specifically parallel circuits. Now, I'll give you a bird's eye view of the specific question, how you need to solve that, or how you need to approach it at least. And then I'll give you a short demo from the real question, what it looks like when I give you the video memorandum of that specific question. When you look at a question like this, where they typically give you two machines, two people, of something working together, that's the important thing. They give you a certain amount of time typically that these two people or machines would work together, and then they want to know how long will one of the two work. So you need to look at this question from the perspective of a science parallel circuit in electrical circuits. So typically what would happen in electrical circuits, you would have something like this, just rough drawing of a parallel circuit, and then in there you'd have a resistor and another resistor, and let's say that one is 1 ohm and this one is 10 ohms. What you need to do is to find a way, there's a specific formula that you can use to replace both of those as if there is just one resistor. That's the whole point of finding the total resistance of a parallel circuit. How much would it take, or what type of resistor would it take to give you just one resistor in the place of the two? Now that exact same formula, that exact same logic is applied when you are working with two or more machines. Treat every one of them, each one of them, as if it is a resistor in a circuit. Use the same formula, and for the resistance you take the times that they give you and you calculate the missing time. Just remember this very specific one. There they give you hours and minutes. You need to find out, are you going to work in minutes or are you going to work in hours? Well, you need to determine that at least for yourself if there are no instructions in the question. But don't work with minutes and hours, because then your question will not work out and the answer will not make any sense. So just convert it either to hours and stick with that, or convert it to minutes and stick with that. So that will then give us 2,4t plus 4,8 plus 2,4t is equal to t squared plus 2t.